Language, even though it may not seem like it in everyday life, is a computationally challenging task for the human mind. In these two experiments, we are setting out to explore a small part of language processing, specifically one way that the human brain attempts to alleviate some of the cognitive load during comprehension. The left inferior frontal cortex, or LIFC, which includes Broca's area, has classically been thought of as a language production part of the brain, which is separate and distinct from the language comprehension areas. However, recent theories have suggested that this language production area may be recruited for the language comprehension processes. A theory has been proposed that the language production area uses information from the ongoing context to predict possible upcoming words and start pre-activating features of these predicted words like phonology and semantics. Thus, a predicted word would be easier to process than an unpredicted words. We have designed two experiments to explore how effectively predictable versus unpredictable words based on context are encoded into long-term memory, and if the classical language production area of the brain has a part to play in these predictive processes. In experiment 1, we used a behavioral measure to explore how well predicted words versus unpredicted words were stored in long-term memory. 32 participants completed a categorical decision task. In this task, participants were presented with a category followed immediately by a target word. Participants were then asked to decide whether or not this target word fit within the category. There were 120 categories with matching target words that were either highly typical of the category, predictable words, less typical members of the category, unpredictable words, or out of the category, incongruent words. For example, if the target category were a kind of juice, the predictable word would be grape. Pear would be an example of a word that would be considered unpredictable because it's still part of the category but does not readily come to mind. An incongruent or completely out of category word would be nest. A surprise cued recall test was given to the participants after the task was complete to determine which of the category words were stored in the long-term memory. Results from experiment 1 showed words that were part of the category were remembered much better than out of category words. More importantly, we found that more predictable words were remembered better than unpredictable words. Thus, in experiment 1, we were able to establish that there was a predictability memory benefit. In experiment 2, we investigated whether or not the classical language production area of the brain, or left inferior frontal cortex, plays a role in the effect established in experiment 1. 32 participants completed the same categorical decision task that was used in experiment 1. While participants completed this categorical decision task, they received 5 Hz of repetitive transcranial magnetic stimulation, or RTMS, during the defining word of each category. 5 Hz RTMS has been shown to have an inhibitory effect on speech production. TMS involves using fast-changing magnetic fields to non-invasively and safely induce transient changes in the brain electric activity during stimulation. TMS is a way to establish a stronger causal connection between brain and behavior than other non-invasive human neuroscience methods like EEG and fMRI, since we are inducing the change in activity instead of just measuring it. RTMS was administered during the category-defining word for each category presented, not during the presentation of the target word. For example, if the category was a type of tree, the stimulation would be delivered at the word tree. It is thought that the inhibition of the category-defining word will disrupt the predictive processes that may be giving a prediction boost in the memory processing of subsequent target word. Both the LIFC, which is the target of our experiment, the right inferior frontal cortex, the control of our experiment, were stimulated in counterbalance blocks. A surprise cued recall test was also included after completion of both blocks of experiment 2. We found that the stimulating the right hemisphere did not disrupt the predictive processes, and we saw the same pattern that we saw in experiment 1 for this block. That is, we still saw a predictability memory benefit. However, results from the RTMS stimulation to the LIFC showed a complete elimination of this predictability memory benefit. Overall, the results from these two experiments suggest that there is a benefit to encoding predictable versus unpredictable words into long-term memory. These results also suggest that the LIFC is recruited in predictive processes, which challenges traditional views of function of the LIFC, including Broca's area, as only playing part in the language production